Welcome back to Bitcoin and Beyond. Today we have Dom, the co-founder of Build on Bitcoin, for a presentation about what they're doing with merge mining, their hybrid L2, and some other interesting technical topics. Dom, welcome. Thanks for being here.
Hello, welcome. Thanks for having me. Great to meet everyone. I'm Dom. I'm one of the founders of Bob, and we started Bob last year essentially as we saw, ordinals, BRC20s, runes. Well, runes were announced last year, but anyway, we saw like this newfound interest in building on Bitcoin, and that's why we decided to name the project Bob to make it a lot easier for people to build on Bitcoin. And I'll walk through a little bit about what we're about, and then do a deep dive on what makes Bob special with this merged mining technology that we have. Right. So, Bitcoin has like 300 million users right now, and it's growing faster than the internet, which basically means we can sit back, relax, and just take history takes its course. Or technically, we could do that, but we actually see a big problem where you have a huge difference between the Bitcoin space and say Ethereum and other L1s, L2s, where Bitcoin mostly focuses on mass adoption, like real world impact, which is great. But then new things around, zero knowledge proofs, account abstraction, DeFi, stable coins, that all happens kind of in other ecosystems because it's really hard right now to build on Bitcoin, actually. A lot of teams are trying quite hard, and there's just still cool things being done on Bitcoin. But if we are quite realistic, then very often if you meet people that are getting into the crypto space, they might hear first about Bitcoin, but if they're actually ending up building something, they typically go rather to Ethereum or Polygon, Arbitrum, one of the EVM chains, because if you look at how easy it is to write a smart contract in Solidity versus how hard it is to write a Bitcoin script, you'll quickly realize that's kind of one of the key reasons. So really, why we exist is like we wanna bring back this innovation to the Bitcoin space, and do that via a L2, as many others are doing it right now. And I think there's this new we called it the Bitcoin Renaissance in Denver. There was the Bitcoin Renaissance event that we hosted with Babylon together, and it's just grown since then over the last few weeks and months. And there's so many new projects now sharing that same vision, and we think it's really worth it to bring all that innovation to Bitcoin. We think that to do a Bitcoin L2, there's kind of three major problems that need solving. The first is the Bitcoin problem. And by Bitcoin problem, we mean the L2 needs to be aligned with Bitcoin as an ecosystem, and it needs to get Bitcoin security in one way or the other. And the second problem and third problem is something that we don't see as much tackled by other L2s out here. One is ecosystem. So you want to have a very thriving set of apps already live. You want to be able to build on top of other things. So if you look over at EVM chains, you can use the Open Zeppelin contracts. You can build things on top of other protocols. People call it money Legos in DeFi. And really, that's very powerful, that network effect that you have if you use the EVM. And third thing is liquidity. So if you have a lot of users and liquidity already on a chain, it's really easy for these users and that liquidity to move over to other projects. So if you're a new project and you want to try out something, then it's great to launch on a chain where there's a lot of traction already. And the way we are approaching it is kind of unique. I think we're the only ones that are trying to do what we term a hybrid L2. So we have a rollup that's going to be secured by Bitcoin, integrated into the Bitcoin stack. via like clients, and we do want to have integration with Lightning and Nostr and Ordinals, BRC20s, runes. But we are also a rollup on Ethereum, just to make it super easy for users to come over from the ETH space. A lot of people are used to, bridging over from Ethereum to Arbitrum or to Base or to Optimism, and bridging between like these L2s, and that has proven to work quite well. And we think that that's kind of the way forward. Just so if you're a project and you want to build anything with Bitcoin, usually, and it's DeFi, you want to have access to stablecoins. And instead of convincing Tether and Circle to have dedicated deployments on our L2, it's really easy for us to bring over USDT and USDC directly from the Ethereum network. And that's what makes us kind of special in this realm of L2s that are popping out right now. And how that kind of works under the hood is, if you look at the Bob stack, like it starts at the rollup layer all the way down there. That's based on the OP stack. So it's an optimistic rollup. It's rolling up to Ethereum. It uses Ethereum as a DA. Has the EVM core on the layer up, so you can use any of the EVM wallets. You can use Hardhead Foundry. You have safe multi-sig, so you have all this tooling out of the box, and you don't need to do anything special. So if you're a new project, you can get started right away as if you were in any other EVM chain. If you're a user, you can use it like any other EVM chain. And where then we come in and make it kind of special is with the Bitcoin bridges. So we have dedicated support for that. We have an on-ramp that's going to launch for like an on-ramp from Bitcoin that's going to launch very soon. We're working together with RiskZero and others for ZK stuff. And then we have this Bob SDK that helps you if you're building an app and want to interact with Bitcoin to just make that a lot easier. And that includes a few things like being able to prove that things happened on Bitcoin via like client, but it also includes like some helper libraries for Bitcoin transaction signing, UTXO selection, and so on and so forth.
Nice. Yeah, I haven't tested out Mainnet too much yet, except for just kind of browsing over some apps. But from what I'm understanding is that this should basically feel like an Ethereum rollup from start to finish for users who are accustomed to using EVM rollups.
Yeah, right, exactly. So we didn't make any changes to how the EVM works. So for users, exactly the same experience as if they were using Base or Optimism. And for projects, it's exactly the same experience as well, with the key differentiator that you can access Bitcoin tooling if you also want to interact basically with Bitcoin.
Yeah, exactly. Cool.
Nice. All right, and then let's look a little bit where we are right now and where we're heading, and then look a bit deeper into this kind of under the hood stuff. So we believe in this pragmatic way to decentralization. So right now, we completed phase 1 of Bob. We launched Mainnet on 1st of May, and that's what we call the bootstrapping phase. We are right now an optimistic ETH rollup using the OP stack, and right now we don't have Bitcoin security. Right now we're working towards phase 2, which is being an ETH rollup with Bitcoin proof of work security through merge mining. And we'll go into a lot more detail around that in a bit. But it really doesn't stop there. And phase 3 is moving from being an ETH rollup to being a Bitcoin rollup. And what we need for that is we need to be able to verify actually that what the rollup does is correct on Bitcoin itself, and that's not possible right now. And there's kind of 2 major ways to get there. One is BitVM. So for those of you who don't know BitVM, it's essentially a way to do fraud proofs on Bitcoin, and it's right now it's mostly a research proposal where a few people work on it. We don't have a finished implementation yet, but us and a lot of other people hope that in a few months we can get to a good understanding of how a protocol would look like to do BitVM bridges and how to do BitVM rollups. And from the other, the alternative, if you don't use BitVM at some point, phase 4 for us would be being a ZK rollup. If Bitcoin would add like the necessary opcode or opcodes to verify ZKproofs on Bitcoin. For phase 3, we think that maybe in a year from now-ish, we could have some sort of production implementation for BitVM. But phase 4 is realistically, I think, like, I don't know, at least 3 to 5 years out. There's not, one universally accepted ZK standard there. And it will, being, there's a good chance also that Bitcoin will never actually add a ZK opcode. Because we can see right now, for example, with OpCat, how lengthy the discussions are and how difficult it is to change Bitcoin core. Also because it's Bitcoin is made to be quite resilient, right, and cautionary about changes. So I think like it will take a long time until we have some sort of ZK opcodes on Bitcoin, if that ever happens.
Could you give us a quick sidebar on OpCat and what is that opcode?
Right. OpCat is quite the discussion right now. So everybody talks about OpCat. OpCat is actually an opcode that there used to be in Bitcoin, but then it was removed, and now people talk about adding it again. The key thing that OpCat will allow is basically to concatenate two hashes together. That's very useful if you want to verify, for example, a Merkle tree inside of Bitcoin script. And right now you can kind of do that, or well, you can do it in BitVM. It ends up in very long scripts, and there is a maximum script size basically in Bitcoin. With OpCat, we could reduce the size of the script quite a bit, because there would be, now we need like a lot of opcodes to emulate like this concatenating two hashes. We could replace that with a OpCat with like a single opcode. But there's a lot of discussion right now what kind of that would introduce to Bitcoin, and it's a bit there's very loud voices on Twitter going forth and back against this. So yeah, that's a currently ongoing discussion. It would help BitVM, but looks like Robin is now kind of against it. So yeah, I don't know. But yeah, OpCat is essentially a new opcode that would make BitVM more efficient.
And what's the trade-off? What's the downside?
So the downside is by introducing a new opcode, it's kind of unclear what implications that would have directly on Bitcoin. So since you could do new Bitcoin scripts with OpCat, very similar to how we had Taproot, and then people discovered, oh, we can do ordinals now and inscribe arbitrary data to Bitcoin. And then, okay, we can actually do BitVM arbitrary computation on Bitcoin. OpCat could enable like new use cases, and there's a crowd of Bitcoin Core users that are opposed to enabling it, because they say it's basically unclear what kind of new things that could introduce, and if it could add some sort of new MEV vectors, versus there's the other kind of crowd mostly around Taproot wizards, right, that want to add that so we can create more efficient scripts.
Okay, got it. Thanks for taking us down that little rabbit hole.
No problem. I think there's a lot of good ongoing discussion online, and you can follow some on the GitHub issues as well. But it's quite a involved discussion at this point. Cool. All right. Let me dive a little bit deeper now into what we have done so far and what we're going to do next. So right now, as I mentioned, we're on mainnet with the phase 1, like the bootstrapping phase, optimistic ETH rollup. So it's all quite simple. It's OP stack, so you would just use it like Optimism or Base, and for Bitcoin bridging, it uses wrap BTC and TBTC from Ethereum mainnet. So those are wrap BTC is a centralized version, and TBTC uses like a set of signers, or distributed set of signers to secure the Bitcoin. So there's no decentralized Bitcoin bridge as such, but these are really battle tested, been live for years, and that's where we are right now. And oh yeah, just to kind of recap quickly on how that works, if people are not familiar fully how optimistic rollups exactly work. You basically have a sequencer, and that sequencer produces blocks every 2 seconds for the Bob L2. You have a Ethereum Bob bridge, and you would finalize the data directly on Ethereum, and the interaction with Bitcoin is basically via a light client. And what a light client does is you can read state from Bitcoin directly. So if you wanted to, for example, do a peer-to-peer swap between, say, USDT on Bob and Bitcoin on Bitcoin, you could essentially lock some USDT and say, I'm going to sell, I don't know, 60,000 USDT for 1 Bitcoin. And then somebody could go in and say, yep, I'll take this, and then submit a transaction inclusion proof from Bitcoin to prove that the Bitcoin actually moved over to the person that was selling the 60,000 USDT. So it allows you to do trustless reads from Bitcoin. And the BTC relay is live on Bob mainnet, so other projects can use that. We're submitting block headers there. So yeah, you can do transaction inclusion proofs on that right now.
And right now the only Bitcoin available on Bob are these effectively these custodial versions, which have been trusted for some time. But once you have the Bitcoin bridging aspects implemented, is there going to be something more like a native Bitcoin implemented into Bob, or like a less custodial, more trust minimized version?
Yeah, so we are working for us. BitVM is the key enabler to do kind of trust minimized bridging, where pretty much everything right now is some variation of having multiple signers. So you can wrap BTCs like you basically trust BitGo and their signers. So it's like a small multisig. TBTC is a lot more decentralized in that way, where they have 100 different signers, but it's still like a restricted signer set. But with BitVM, we can actually go to a 1 of n trust assumption. So you just need like one honest entity in that set of signers, and you could join yourself if you're technical enough and would have the necessary funds to fraud proof. And we think that's the future. But as mentioned, like we are not. BitVM isn't in the state yet where you can actually implement a bridge.
Cool. And then for now, for Bob sequencers, it's the same sequencer type as like Optimism, like you said, or Base. It's like a single sequencer with no fraud proofs at the current point.
Yeah, that's correct. So right now, single sequencer, no fraud proofs right now. The same as like Optimism and Base. The OP stack has its fraud proof right now on the Sepolia testnet. So we're basically waiting for that to be finalized and being able to merge on mainnet, so that we can get permissionless fraud proofs on Bob the moment that's ready on Optimism as well. And that's a great question, because we don't like centralized sequencers either, and that's where actually like this phase 2 now comes in. So the phase 1, like it gives you a basic chain, right? So if we started, the project is called Built on Bitcoin, right? So we actually need to do the connection to Bitcoin. but at least the building part, like people can build now something. And we decided to go with merged mining for phase 2. And what does merged mining do? It's a very old kind of technology, so it dates back to 2012, and that's practically ancient in blockchain terms, I would say. But before like diving deep into how it works, give you like a why my merged mining is interesting, and especially we have this new protocol we call OptiMine, which is optimistic merged mining, and it gives us some interesting properties. So compared to standard Ethereum rollups, we can get actually faster finality by you have the centralized sequencer. Even if you have decentralized sequencers, you basically verify that the rollup is operating correctly, and Bitcoin miners do that verification, and there's a proof of work associated with that. So they have a proof of work that they actually validated this rollup, and then you can settle the rollup quicker, and you can get finality over the transactions. And we remove a lot of trust in that centralized sequencer, or even if there's multiple sequencers, by having independent parties validate what's happening. And compared to Bitcoin sidechains out there, we can, with this optimistic merge mining, we can get a lot faster block times than current merge mining chains. So the biggest one being Rootstock at the moment. They have 30-second block times, which I guess is okay, but in terms of like user experience, it's kind of nice to have fast transaction confirmations. And with this optimistic merge mining, we can do the OP standard 2-second block times and maintain those. If you do merge mining the traditional way, like your lower bound is around 15 seconds. Below that, there's limitations in the Bitcoin mining, the way the Bitcoin mining works, where like your uncle rate becomes way too high. Merge mining is also our first step because it doesn't require any Bitcoin forks or updates, so it works right now, which with VM, as I mentioned a couple of times, like it's not ready for production yet, and ZK opcode or ZK verification on Bitcoin also isn't possible right now and will require a fork. You also get like a nice little property of like consistent block fees. So for miners, because they will mine actually multiple blocks at the same time, you get like evening and out payouts, which addresses some of the concerns around MEV. And as a general comment, we are reusing the proof of work from Bitcoin. So Bitcoin miners use exactly the same proof of work to mine Bob as they mine Bitcoin. So you don't have any extra electricity that needs to be spent when merge mining Bob. So you don't, miners don't, the energy impact basically doesn't change from just mining Bitcoin to mining Bitcoin and Bob together. Cool. So let's dive a little bit into this OptiMine and how it works under the hood. With OptiMine, which is our optimistic merge mining protocol, we're separating block production and block finalization. Then step one, you have the sequencer process all the transactions and generating blocks every 2 seconds. That is optimistic, so that there is no change to that compared to like traditional OP stack. So that functions exactly the same way. Now, where we do a little trickery and changes is on the block finalization. So without OptiMine, you basically block finalizes once the proposer in the OP stack submits the L2 block hashes to Ethereum, where it settles, and then you have this challenge period. So within 7 days, you can challenge fraud proofs are live. So you can challenge the L2 blocks essentially and say like, oh, I think this block should have been different, and then you submit this fraud proof and you start this on-chain game of proving fraud. And what we basically now do with OptiMine is Bitcoin miners run a full node of Bob, very similar to how challengers would run full nodes of Bob in the plain OP stack case and do ZKproofs. But in our case with OptiMine, the miners actually include a hash that refers to a whole bunch of Bob blocks into a Bitcoin block, into a very specific part in the Bitcoin block, and they put this together. They merge mine, and merge mine basically means they are trying to find a Bitcoin block that matches the difficulty of the Bob chain, and then they submit that to Ethereum, and the smart contract on Ethereum verifies that the proof of work is actually correct, and then we would consider Bob to be finalized if we have enough proof of work accumulated. That gives us two things. So first of all, you get Bitcoin security by merge mining, and it's the amount of Bitcoin security you're getting is based on how many miners would opt in to merge mining Bob. So the more miners you get, like the more Bitcoin security you get. If you get 100% of Bitcoin miners, then you get exactly the same proof of work security as Bitcoin itself. If you get 50% of the miners, you get 50% of the proof of work security from Bitcoin. As for Ethereum security, since the smart contract actually for the Bob chain verification lives on Ethereum itself and not on Bob, you get like the full Ethereum consensus security because it's like all the Ethereum validators do validate the correct execution of that smart contract.
Gotcha. Okay, so a couple of things here. First, why is there always going to be miners from Bitcoin to verify Bob blocks without any like without problem? And if there or like what would be a situation where miners may not be as incentivized to mine blocks from Bob than they typically would a different type of transaction or a different or if there's a lot of transactions happening, like I guess, is there a situation where they would not mine those blocks or verify those blocks?
Yeah, I would imagine that if there's basically no fees that Bitcoin miners could earn, they wouldn't be as inclined to merge mine it. But in that case, like I'll come to that actually in a bit. But if Bitcoin miners would like, if there was no miner mining on Bob, like the rollup would basically halt, like because at that point we wouldn't have any Bitcoin security anymore. So with OptiMine, like it can be configured, right? You can just do it informational, like okay, right now we don't have Bitcoin security, but still continue to produce blocks optimistically. But the way that we think about the protocol is there should be like a timeout. So if we don't have a Bitcoin miner validating the blocks for like say, I don't know, 4 hours, and I say 4 hours because that's similar to how ZK rollups on Ethereum validate on Ethereum. So if we don't have any merge mining security for 4 hours, probably something is wrong, and then we should halt the rollup and see what's actually happening. If that answers your question.
Okay. Yeah, it does. And then when the Bob smart contract on Ethereum verifies the proof of work from the Bitcoin side, how long does that process actually take?
Oh, that's super
just
quick.
like one block?
Yeah, it's just one block. It's just one transaction basically. So what you do is I'll come to that actually in a bit, but the Bitcoin miner submits basically a Bitcoin block that has a reference to Bob in the Coinbase transaction, and that submits that, and it gets checked in a smart contract. So that's like a single transaction basically on Ethereum, and that does two things. Like it first verifies that the proof of work is correct and valid, and then it submits it for the miner, and then the miner would actually then have a claim on the fees that are generated in the Bob network.
Cool. And I guess like the last one is how much more decentralization do you think using Bitcoin security and using miners versus like proof of stake and Ethereum's validator network provides? Like I understand that you kind of get the best of both worlds, but I'm curious, like, do you think that Bitcoin is more sufficiently decentralized in terms of like verifying transactions than Ethereum?
Interesting question. I think it's just a very different approach to validating that things are correct, right? So I think Ethereum is pretty set on, proof of stake works quite well there, and it's well, it's proof of stake validation on the Ethereum side, which is a game of kind of capital. There's a lot of stuff going on the Ethereum side with MEV and specialized block builders. Versus Bitcoin is quite different because it uses a different mechanism with proof of work essentially. So it's a lot more, miners and Bitcoin usually run large farms of hardware actually in data centers and searching for cheap electricity. So it's kind of like a different crowd of organizations and people. And I think by bringing them basically together, you get a more decentralized set of validators for your rollup because you don't only have the proof of stake or only have the proof of work crowd, but you actually bring them both together to both validate the Bob rollup.
Yep. Yep, makes sense. Cool. All right. Yeah, I think we can go forward here.
One more question, Dom, on
Yeah.
merge mining. From my understanding, there's a couple rollups or protocols that already rely on merge mining. I'm curious if, like, a couple things, like if you are aware of like what the current adoption rate is and how many miners are merge mining those other rollups. And I'm curious, is there like an upper limit as to the mining power that we can merge mine? Like if I choose to merge mine to one rollup, can I do so with 100 Bitcoin rollups? Is that possible, or do I have to sort of split up my resources if I am going to merge mine multiple rollups?
Yeah, that's a great question. Let me actually answer the second part of the question and then get back to the first. Like, let me answer can I merge my multiple rollup sidechains at the same time, and then how does adoption look like? And let me quickly jump forward to this slide. Sorry, that's a tad bit technical. So, but to answer that question, like it will make a lot more sense. So on the left-hand side, you have like a merged mined Bitcoin block. And merged mining basically means you as a Bitcoin miner, what you do is you have a Bitcoin block, and the Bitcoin block is like consists of like a block header, which the version, previous block, reference, the Merkle root, the current time, bits, nonce, and then you have the transactions in there, which is a very special one. The first one is the Coinbase transaction, which gives you the Bitcoin block rewards, and then you have more transactions in there. Now to go a tad bit deeper into details for actual mining. So mining follows a Poisson process, and that means that if you change, so what Bitcoin miners basically do, right? They, if all the transactions would stay the same all the time, they would just change the nonce in the block header until they find a Bitcoin block that has enough leading zeros to meet the Bitcoin difficulty. That's what mining is, right? You try to find a block hash that has enough leading zeros for Bitcoin difficulty. Now, because it's a Poisson process, so your probability to find a block doesn't change if you change out things inside of the block. So that's why basically Bitcoin miners all the time they swap out like what I wrote here with transaction 1, 2, and so on and so on. Like they change out these transactions which are actually included in a block by which transaction basically pay them the most fees. In return, that also means if we change things in the Coinbase transaction, then your probability to find the next Bitcoin block doesn't really change. So let's have a quick look inside of that Coinbase transaction. So Coinbase transaction is the very first transaction inside of a Bitcoin block, and it has exactly one input, which is the block subsidy. So that's the miner reward. So when we in April talked a lot about the halving was exactly the block subsidy. The miner rewards were slashed by 50%. And now we have the outputs of this Coinbase transaction. So UTXO-based model, one transaction is inputs and outputs, and Coinbase transaction is exactly one input, and then we can have multiple outputs on the Coinbase transaction. And the first output, look, if it's a standard non-merged mine Bitcoin transaction, typically there's often only a single output, which basically transfers the block subsidy to the Bitcoin miner's account, wherever they want to have that. Account is not necessarily the right word in the Bitcoin context, but like the address of the Bitcoin miner. But now we can actually add a whole bunch of extra outputs to that Coinbase transaction, and that's what happens in merged mining. So you would typically add an op return output. An op return in Bitcoin is a way to include small arbitrary data. It's usually most miners only accept it to 32 bytes. You can, in theory, add a lot more bytes there. So, for example, Marathon runs this kind of service where you can mine transactions with larger op returns. But anyway, don't want to get too sidetracked. And you can, so to answer your, in a very roundabout way, to answer your first question, can we merge mine multiple chains at the same time? Yes, you basically only need to add more outputs in the Coinbase transaction. So you would have one op return to merge mine on Rootstock, one op return to merge mine Syscoin, one op return to merge mine, say, Namecoin, and then one more output to merge mine Bob. And those would all be valid. Now, the last step we need to do for merged mining is miners do this mining and they're trying to find a Bitcoin block, but all the Bitcoin, like the rollups and the sidechains, they have a lower difficulty than Bitcoin itself. So let's say, just for sake of argument, you need like 10 leading zeros to find a Bitcoin block. Maybe you need only 7 leading zeros to find a valid block for Rootstock and for Bob, and they have the same difficulty. Then now you found a block that has 7 leading zeros, but it doesn't have 10. Now what you do as a miner is you take that Bitcoin block with 7 leading zeros and you submit it to Rootstock and you submit it to Bob, and then you can claim basically the transaction fees on Rootstock and on Bob, and it can be like the verification basically then on the other side is this. You verify that the merged mine Bitcoin block meets the Bob rollup difficulty or Rootstock difficulty, and you reject it if it doesn't have enough difficulty, so leading zeros, and you verify that the op return output, so the one that we put in the Coinbase transaction here, that this actually refers to Bob block bundles. In our case, or for Rootstock, it's that they have slightly different checks. So you can merge mine multiple rollups at the same time, and there's no extra cost for mining, basically, because you're reusing the same proof of work for all of those rollups at the same time, or all of these sidechains at the same time.
Got it. Okay. And so let's say I am running a miner and I include the merged mined outputs for some various Bitcoin rollups. And let's say Andy's running a miner, but he doesn't include the outputs for those rollups. And let's say, we're competing to try to find like the Bitcoin block, right, for the next hash. If Andy finds the block and he doesn't include the outputs, does that mean that that for that Bitcoin block, there's no verification of the Bob rollup?
Yeah. So yes. The this is one of the super common kind of slight that that makes merge mining a little bit hard to understand. So actually having the op return on Bitcoin itself isn't necessary for merged mining to be valid. So in the case where Robbie, you're a miner, and Andy, you're a miner, and Robbie, only you do the merged mining and Andy doesn't do it. Robbie, what you're basically doing, if you find a block with these 7 leading zeros, then you submit it directly to Rootstock and Bob. And these Bitcoin blocks will only ever be stored on Rootstock and Bob. And they will never be part of the Bitcoin blockchain because they only have like 7 leading zeros. And the only case where like a op return output of like merged mine sidechains or rollups actually end up in Bitcoin is if by chance you're finding a block, a valid Bitcoin block with say the 10 leading zeros, and then you would put that onto Bitcoin. But you would always check the merged mining security from the perspective of the sidechain or the rollup to which these Bitcoin blocks are submitted.
And
That's
so, yeah, I think that makes sense. But so does that mean that the difficulty of mining a block on Bob does not equal the difficulty of mining a block on Bitcoin?
Yeah, that's correct. That's correct. And it always should be lower than the Bitcoin difficulty, because well, unless you would have a lot more fees on Bob than you would have on Bitcoin, like miners would never spend, like, let's say they find a Bitcoin block, right? But it's not yet a valid block in Bob. So they need to continue mining. Like that doesn't make sense unless they would get a lot more money for mining on Bitcoin. So your difficulty on any sidechain and rollup would be upper bound by the Bitcoin difficulty.
Do you think it's possible that like after the block subsidy is depleted and there's only transaction fees, do you think it's possible that a Bitcoin rollup like Bob generates more transaction fees than the Bitcoin L1?
It's possible, yeah. I mean, it's possible. There's a lot of unstable regions when the block subsidy basically runs out. Where yeah, so Bitcoin miners might actually get more fees on rollups or sidechains, and Bitcoin miners might actually stop or halt their miners altogether if they don't get enough fees on Bitcoin. So it's possible.
Okay, but okay, this by generating fees on Bob, it could persuade miners to keep their miners running, because not only would they get the Bitcoin L1 transaction fees, they would also get fees that originate from Bob.
Yeah, exactly. So it's a way to kind of help miners essentially keep Bitcoin mining running, and using merge mining is kind of a decent way to make sure that Bitcoin miners are incentivized to keep on running their mining hardware, even if it wasn't directly profitable to mine on Bitcoin directly, but they would get the additional fees from Bob or other sidechains / rollups that would use merge mining. Cool. And to kind of go back to your first initial question around miner adoption, what we've seen so far, I think Rootstock has been the one that had the most miner adoption, with about 80% of the mining power, I think. Now I think it's back down to I'm probably gonna not tell exactly the right number right now, but I think it was around 50% or so. So it's like merge mining is essentially opt-in, and the more miners you have, the more Bitcoin security you get. To go quickly, maybe back on one of the first points that I made with like this consistent block fees. So There's one like major difference to our optimistic merge mining protocol to kind of traditional merged mining, and that's on the slide here. So on most, or traditionally when merge mining was conceived, like the task of a Bitcoin miner was actually to also assemble the blocks of the sidechain or the rollup. But in our case, we are using the sequencer for this. So we have this, the thing that I mentioned here. We have the split between block production and block finalization. And we only get on the block finalization, we do merge mining, but the block production actually doesn't use any proof of work. So in our case, like in the lower part of this little graph here, we have in blue from 1, 2, 3, and -1, and those are the Bob blocks, and then up there, there's in orange, there's the Bitcoin blocks, and then what we include is a block bundle, and a block bundle is a hash over multiple block Bob blocks. So let's say block 1, 2, 3, and -1 and n. Those all have their own hashes, and then we put these hashes together and derive a block bundle hash. And what that gives us, let's say a Bitcoin miner wouldn't verify like a single block via merge mining, but they would verify, say, 100 or 1,000 blocks all at once. And the key interesting difference there is if miners are allowed to produce blocks as well, then it's a big worry if you don't have enough miners in the system. Like if you don't have enough mining power, then there have been cases where kind of other miners attack chains. So if in our case, basically all the miner can do in terms of attacking is they can just stop merge mining that chain, which would then halt finalization. But as long as we have some miner validating it, we're okay. But if you also do block production via merge mining, miners can create forks of the sidechain or the rollup. And that means if you have, I don't know, maybe just like 1% of the Bitcoin mining power, then a miner with like 2% can come in and create like competing forks for your chain, which then need to be user resolved, and has created quite some issues for merge mining projects in the past. And yeah, that's kind of an issue that's solved through optimistic merge mining by exactly doing the split of optimistic block production versus miners only on the verification part. And this is where we basically come in, like in terms of the consensus rules. So in terms of liveness, failures, we require merge mine blocks every X minutes. We still need to figure out exactly the parameter, but otherwise we would halt the chain, and then we would resume once merge mine blocks are submitted again. But really all miners can do is like halt this thing. And for safety, there's no additional safety concerns introduced via miners in that sense. So you could still fraud-proof things, but in our case, you would, if you have sufficient proof of work being submitted, you have miners basically validating in the rollup. So if they disagree with what the sequencer was putting on chain on Ethereum, they would trigger the fraud proofs.
Okay, so in a pre-fraud proof environment, would disagreeing with the miners, would this cause a halt? Like, is there a way where somebody can understand this consensus model and just purposefully disagree and just cause halts?
Yeah, so again, this depends a little bit of how we. Initially, I think we would. It would be just flagged like, "Hey, miners don't agree with this. We probably need to resolve the situation," because it might just be like a software bug. But in the like proper final production version of this, it will actually halt even pre-fraud proof. But we kind of, the way we want to actually implement it is that we do this together with fraud proofs, because we want to actually integrate that into the kind of fraud proving logic into the OP stack. But yeah, essentially you would follow.
Got it.
Cool. All right. Yeah. So OptiMine really, like, just to summarize it, it's a kind of new optimistic merge mining construction, and it allows you to do some cool and interesting things to get in Bitcoin security basically right now without doing any hard forks. And we're currently working on the implementation. So there's a few implementation details that I glossed over a bit, and also some things that we're still figuring out in terms of like the mining timeouts, and then the actual implementation issue of getting this properly implemented into the OP stack. So if there's anyone who's super interested in that topic, we'll share kind of. We have the protocol on our website, but we will share some more of the implementation details if people want to look at it. That's really cool for us, and we actually encourage that. Cool. Do you guys have any more questions on optimistic merge mining? Otherwise, I would.
Nope. I think we're good there.
Awesome. Cool. Right then. Quick recap. So basically, we're phase 1 now. Phase 2 is merge mining that I talk quite a lot about right now. That's what's currently being implemented. The research that we're doing at the moment is towards BitVM, but given that I don't want to talk for another hour or so, I'm skipping the BitVM part right now. But it will. The step 1 for us is like get a bridge working with BitVM so we can optimistically, bridge and do fraud proofs, so that you can have. I think one very important property of L2s is that you can withdraw always to the L1, and right now that's possible to Ethereum, but it's not really possible on Bitcoin, and a BitVM-based Bitcoin bridge would allow us that. And that's the, towards the end of the year, next year is when we think that can launch into production, and then eventually maybe ZK if Bitcoin actually adds the opcodes for that. And in terms of, just to give the quick glimpse on the BitVM, is basically we would still have merge mining. We would still have like kind of sequencers, and they would run this BitVM stuff. The merge mining is actually super useful in BitVM context. I think people are sometimes surprised by that. But if you do BitVM, you want to have a light client on Bitcoin that can verify the other chain or rollup. And merged mining gives us a very good notion about finality. So if we have enough proof of work accumulated, like a certain percentage, like a certain difficulty, we could say that that Bob is finalized under the perception of Bitcoin mining, and it helps quite a bit with light clients, because, for example, building light clients for Ethereum right now is quite difficult with the Ethereum kind of signature aggregation into reason about finality, and that concept is pretty hard. And merge mining actually helps us with that because we can use that as a form of finality in BitVM. And so if all ever goes right, then nothing's really needed on the BitVM side. You just have the BitVM part, and if something goes wrong, you have disagreements, then you would basically do fraud proofs inside of BitVM on Bitcoin, and then you would relay the outcome of that fraud proof back to Ethereum, so that you keep both Bob as like a hybrid rollup, that you would synchronize the fraud proving state between Bitcoin and Ethereum. And this is a very open research problem. There's a lot of details that need to be figured out once we start working on the implementation, in terms of like when are we actually allowed to settle on Ethereum, depending on Bitcoin state. And this will be a very interesting project. And that's the kind of the BitVM outlook. And so we're basically doing Ethereum L1, it's already in, sorry, we're doing Ethereum L2, it's already in L2, obviously with a lot of limitations. Right now, as OP Stack continues to evolve, we want to adopt the fraud proofs, but right now they're not live. And Bitcoin L2, that's the vision. And once we can actually verify the rollup on Bitcoin, we'll make that a reality. But the way that we see ourselves is we want to essentially be the platform in between Bitcoin and Ethereum. And if you have assets from Ethereum, they should have Ethereum security. If you bring in assets from Bitcoin, they should have Bitcoin security, and you should be able to use both on Bob. And yeah, we're on Mainnet. We launched May 1st, so you can go check it out. There's a bunch of apps already deployed. Yeah, and let me know any more questions.
Yeah, Dom. I mean, I think that's about it from our end. That was an awesome presentation. I appreciate you fielding our questions and showing us all of the technicals of how Bob works under the hood.
Cool. You're welcome. And you know, if you guys want to follow up or anybody wants to reach out, like I'm available on Telegram, Twitter. Just kind of text me. Always happy to talk about research and tech.
Sweet. And yeah, as far as our community getting involved, they can scan this QR code and find you guys on Twitter and Discord, etc.
Yep.
Awesome. All right, sir.
Cool.
Thank you.
Thanks a lot.